What is life? Now, if you ask a modern molecular biologist today, the sort you find around the universities and laboratories, they will generally tell you as an answer, well, life is just a special kind of biochemical process which somehow emerged on the Earth as a result of a series of very unlikely chance events. So now you ask the biologist, well, are you alive? And if the biologist is honest, he'll have to answer, probably not. And if you ask them, do you believe that you are just a collection of molecules? Yes, they answer. Then you ask the question, well, tell me, which molecule is talking right now? So we've come to a point where a scientific revolution is needed, is necessary. And the incompetence in method which dominates much of present-day biological research and medical research and other research cannot be tolerated any longer. And there are several reasons for that. On the one side, we are facing right at a global level outbreaks of old and new epidemic diseases and epizoics, diseases of man and animals, and most likely also plants, including AIDS, including malaria, tuberculosis, polio, hepatitis, also new diseases not known before, AIDS an example, BSE, outbreaks of animal diseases. These outbreaks reflect what appears to be a sudden acceleration of the evolution of lower forms of life in the biosphere, of bacteria, viruses, and so forth, as a result largely of the looting and destruction of Africa, of other regions of the earth, as a result of the kind of free trade insanity which has given us these new epidemics coming out of Britain, such as BSE and the revival of the foot and mouth disease, plus the probability of the creation and release of new artificially evolved microbes and deadly diseases from laboratories. If this process continues, then we can't rule out the possibility that mankind might itself become a virtually extinct species within a few generations. And there's no way that the techniques of molecular biology and genetic engineering and all these things can provide an answer to that. Because if the biologist defines himself as a non-living entity, he's not going to be able to compete even with lower forms of life. So we have to act as human beings to win this one. We need a scientific revolution based on the comprehension of the principle of life itself as a distinct active principle embedded in the geometry of the universe. And that means reviving, among other things, or especially the work of the great Vladimir Ivanovich Vernadsky, about whom I'll say a few words a bit later, and actually going beyond Vernadsky in some crucial respects. I recommend, as a reference for everyone here, to study a 1938 article by Vernadsky called On the Fundamental Material Energetic Distinction Between Living and Non-Living Natural Bodies in the Biosphere. You'll find the English translation in 21st Century. We have a French translation. A German one will be published very soon, for those who can't read the Russian original. In that place and other writings, Vernadsky presents a rigorous proof that living processes are an expression of a physical principle which is absolutely distinct from those principles which appear to govern the processes of non-living matter or non-living processes on the Earth. So the attempt by molecular biologists and others to try to reduce the processes of life to chemistry and physics as usually understood are just as silly and futile as the attempts of badly educated people down the centuries to try to square the circle with ruler and compass or do other constructions which in principle are impossible. The circle, as Couse demonstrated, represents a higher species of existence which cannot be reduced to the domain of straight lines and polygons which can be constructed with the usual methods of ordinary geometry. So Vernadsky similarly spoke of a deep, unbridgeable gap separating the processes of life from all other processes occurring on the Earth. But just establishing that there's a crucial difference is not the same thing as conceptualizing the principle of life itself as a universal physical principle. And that's the great work which we have to launch right now. Now somebody comes and says, but what do you mean by a universal physical principle? Well, if you want to know that, I think the best way is to go back and read the Timaeus dialogue of Plato. There, Plato develops the conception that the universe is not an object in the ordinary sense. We can't see the reality of the universe. We see something, but it's not the reality. It's not that sort of object. Can't be grasped by sense perception. Rather, the universe is a process of becoming. It's unfolding according to an idea. Just like a classical composer composes a work of music in such a way that every moment of the composition's performance will be shaped and governed by a single idea, which is the intention of the composer. Just so, the development of the universe as a whole expresses an intention, a universal principle of creation. But by its very nature, an intention can't be seen, but only grasped by the mind. Let's see the first thing. It's from this point of view, for example, that we have to read the meaning of the crucial anomaly of visual geometry, the fact that 5 and only 5 types or species of regular solids can be constructed in visual space. And the uniqueness of these 5 regular solids, 5 species, pervades all of visual geometry and underlies all the possible forms that can exist in visual geometry. More than that, these solids have a hierarchical ordering. All are derivable from one of them, the dodecahedron, and all of them, together with the dodecahedron, are bounded by the sphere, or rather by the action which generates the sphere. And that action, which we could call multiply connected circular action, generates, in the process of generating the dodecahedron, something called, as a byproduct, a geometrical proportion known as the golden mean or the divine proportion. So Plato's reading of the significance of the regular solids constitutes a first step toward a more developed idea, more developed notion done by Kepler, Leibniz, and Riemann, that the highest principle of universal creation subsumes within it an ordered multiplicity of knowable ideas or principles, each of which has a different kind of effect in the universe. These principles, in a sense, are eternal. They're always there. But their mode of expression changes according to the place and time and circumstance and media in which their effect is expressed. So, for example, the idea of man and the principle of cognition predates, in a sense, the physical emergence of man and his mental processes in the universe. So that's the end of Darwin. That's the end of Darwin's silly concept of so-called random variation as the basis of evolution. And in fact, the real father of the notion of an evolution of species, including the evolution of living species, as a directed process not as a random process, but as a directed process. The real father of that notion is Nicholas of Cues, a notion which was brilliantly confirmed by the work of Vernadsky. Nicholas of Cues also launched the development of higher forms of physical geometry beyond the simple visual geometry associated with Euclid and others, but already implied by the Timaeus. The existence of an ongoing process of discovery in the universe, embodied in human creative reason, means that the geometry of the universe cannot be merely spherical, but must embrace a notion of non-constant curvature. And this leads directly into the physical discoveries of Kepler, and from there to Leibniz's creation of a theory of functions, including the so-called integral differential calculus. Followed then into the work of Monge, of Gauss, and finally to Riemann's revolutionary conception of a general geometry or physical geometry of multiply connected manifolds. I would add that the notion, we can discuss this in the discussion period more, but the conception that the universe can only be known from the inside, can only be known through the deliberate experience and re-experience of the ordered history, the historical ordered series of discoveries of fundamental principle, those events of discovery, in a conception in which all a priori assumptions are banned. We look at the universe from the inside as that process, as the generation of valid discoveries. Meanwhile, we're looking at following Nicholas of Cues, we have Leonardo da Vinci, let's see the next one, who carried out the intention of Plato and Cues by systematically investigating all phenomena in the visible universe from the standpoint, from a single standpoint, that we have to, if we seek knowledge of the unseen principles governing the universe, we seek that knowledge by examining and juxtaposing the forms of the most characteristic forms of motion, which are the effect, which reflect the effect of those principles. And here you see just some drawings from Leonardo's sketchbooks. Those who know the articles will be familiar with these, and you should look back at them. Living process, man, the optics, the flow of water, and so forth. So, in particular, Leonardo and his collaborator Luca Pacioli demonstrated that the morphology of living organisms and their internal organization is pervaded by the proportions or geometrical relationships of the golden mean or divine proportion. Whereas the golden section, that species of proportions, is not ordinarily found in non-living processes, at least not on the scale level of bodies, visible bodies on the Earth. This set the stage, let's see the next one, for Johannes Kepler's attack on the anomalies of planetary motion by demonstrating the non-circular, non-constant curvature, approximately elliptical orbit of Mars. Kepler created a paradox. If the path of the planet is not simply circular and is not a simple mathematical function, and if it's changing its characteristics in every interval, changing its curvature in a nonlinear way, then how does the planet know how to move? The orbit and the orbital motion must embody and express the effect of a principle, which is not a precise mathematical number or function, but is nevertheless a distinct principle, a distinct existence. And Kepler called this the mind of the planet, otherwise known as a monad in Leibniz's terminology. However, in causing the effect of the planet's Keplerian orbital motion, the monad does not act alone in isolation. It has to react to, or its action must react to or adjust to, the existence of other monads, of a whole array of other monads in the universe, or active principles. So the result is not a single orbit, but let's see the next one, a harmonically ordered solar system in which the combined action of a multiplicity of principles is subsumed by a higher ordering principle, which Kepler identified in the action of the sun. So this Keplerian notion of universal gravitation, completely different from Newton's silly banalization, was brilliantly confirmed by Gauss when Gauss demonstrated Kepler's hypothesis that the asteroid belt between Mars and Jupiter, this asteroid belt, is the effect of a lawful dissonance generated by the multiply connected, polyphonic, we might say, composition of the solar system. It's a necessary feature of the solar system's principle of composition. On the other hand, Kepler showed that the ordering of the solar system as a whole manifests the same golden mean associated harmonic relations that are otherwise found in living processes on the Earth. And Kepler hypothesized that the existence of life as we know it on the Earth must somehow be connected with the harmonic characteristics of the Earth's orbit within the solar system as a whole. At the same time, in his snowflake paper, Kepler founded the method of crystallography as the first means for science to penetrate from the macroscopic domain of visible forms into the microscopic domain of atomic, molecular, and atomic, subatomic processes. Later, Mendeleev applied Kepler's method to the derivation of the periodic or natural system of chemical elements, which was a crucial input into Vernadsky's work. Next one. Around the same period as Mendeleev, in the middle of the 19th century, Louis Pasteur applied the same method, same Keplerian method, to lay the basis for modern biology and biophysics in mainly two interconnected demonstrations. First, Pasteur demonstrated that the fermentation process, for example, which produces beer and wine, is uniquely the effect of a living process. And secondly, so the beer and wine, as you know, is what you call a product, a natural product of the living process. And secondly, that the products of living processes, as exemplified by the crystals of tartaric acid shown here, up there, which are created in the fermentation process of wine, that these products exhibit crystallographical, or you might say microphysical, characteristics which are absolutely different from those of the products of non-living processes. For example, in all chemical compounds which we synthesize completely outside the influence of living processes, the two mirror image forms of any molecular substance are always produced in equal proportions. Whereas in the natural products of a living process, we find that they generally contain only one of the two forms, only the left-hand form and not the right-hand form, or vice versa, what Pasteur called the phenomena of dissymmetry. Now, with this background, let's turn to the work of Vernadsky, of Vladimir Ivanovich Vernadsky, the founder of biogeochemistry, about whom I very briefly just want to mention a few facts. I can't go into his biography except mention a few things. See the next. So Vernadsky was born February 26, 1863 in St. Petersburg and died in Moscow on January 6, 1945. Here you see Vernadsky in 1905. His father was a prominent intellectual and professor of political economy. His mother, a music teacher and a singer in a famous choir, both Ukrainian. Vernadsky studied chemistry, crystallography, mineralogy, and other natural sciences at St. Petersburg University. He studied under the great chemist and nation builder Dmitry Mendeleev. under the chemist Alexander Butlerov and the mineralogist Vasily Dukachayev, who is a pioneer in the science of soils. In the 1880s, and then frequently thereafter, Vernadsky made travels to France and Germany and other parts of Europe to study. He had a colossal capacity for intense and prolonged intellectual work. He became a kind of universal natural scientist in the sense of Alexander von Humboldt and Alexander von Humboldt's cosmos, at least the intention of the cosmos. At the same time, Vernadsky was a great organizer of scientific and educational undertakings. He founded the Ukrainian Academy of Science. He founded dozens of institutes and research projects, including, not least of all, the nuclear energy program of the Soviet Union, of the later Soviet Union. Already in 1910, you find Vernadsky talking about that nuclear energy would transform man's relationship to the universe. He worked with Marie Curie in the radium laboratory in the 1920s. He launched that kind of research in Russia and Ukraine. And in 1940, Vernadsky took the initiative to bring together the 14-member so-called Special Committee on the Problems of Uranium, including Kurchatov, Khariton, Joffe, Mandelstam, and others, which was the team, which was the core of the nuclear weapons and nuclear energy program of the Soviet Union. Vernadsky was a very political person. He was devoted in the great movement which occurred at the end of the 19th century and beginning of the 20th century. He was devoted to universal education. He was devoted to scientific progress for science, for Russia, for Ukraine, and all other nations. He was already, as a student, a major figure in the Republican ferment. Already 1882, he was in jail for the first time. He became a leader of the Constitutional Democratic Party. He was repeatedly elected to the Russian State Council and held high posts in the Russian government, including Assistant Minister of Education, in the period immediately preceding the Bolshevik Revolution. But probably his most important single post was as the initiator and director of what was called the KEPS, the Commission for Investigating the Natural Productive Forces of Russia within the Academy of Sciences. This KEPS, K-E-P-S, which first in the period 1915 to 1918, and then the second period of Vernadsky's activity there from 1921 to 1930, was set up and charged with the task of comprehensively surveying and mapping out the strategic raw materials deposits and other natural resources of the vast Russian Empire in the context of a economic mobilization. And Vernadsky wrote later that the experiences of his work in the KEPS, quote, radically changed my geological conception of the world. It was in that period, 1917 to 1921, in the middle of the political turbulence and confusion of that period, also in the middle of the ensuing civil war, and traveling constantly from city to city in the Ukraine and the Crimea, creating new institutes and educational programs everywhere he went. It was in that context that Vernadsky made his fundamental conceptual discoveries. So let's reflect, as Vernadsky did, on the implications of what he was doing in the KEPS and related activities. Here was man, Russia, engaged in an economic mobilization. Man looking at these objects, these minerals, these deposits, from the standpoint of man-made processes of transformation, which make ores into metals and other materials, make those materials into machines and other instruments of industrial and agricultural production for the development of man. On the other hand, these same mineral deposits, according to investigations by geologists and geochemists, in which Vernadsky himself played a key role, were showing themselves more and more that these objects, these mineral deposits, were themselves the product of the activity of living processes, of living organisms. mainly microorganisms, but also plants, and indirectly even animal life. This activity going over thousands, even millions of years. How does that happen? Living organisms absorb material, they absorb and digest material and solar radiation from the surrounding environment. They transform that, they organize that material and that energy, they integrate part of it into their own tissue, they also excrete parts of it into the environment, often in a different place from where they absorbed it. When the organism dies, that material is deposited into the environment. So every organism is thus the source of what Vernadsky called a biogenic flux of matter and energy, a flow or biogenic flux transformation process of matter and energy. And not only the majority of mineral deposits of the Earth, but actually the Earth's, the chemical composition of the Earth's atmosphere, of the oceans, and of its surface area down to a great depth, is the product of this transformation process. Thus we can say the biosphere as a whole, let's see the next one, and then the next one after that, quickly the last one. That's Vernadsky toward the end of his life. A very good picture of him. Okay, you can keep it for a moment. So now Vernadsky, in this moment of thinking, he says, looking back at this period, Vernadsky said, a whole new world opened up to me. In the place of the old question, the ancient question, what is life? Vernadsky asked, what does life do? What is the impact, what is the effect of all living processes taken together on the geology and chemistry of the Earth? Suddenly, the entire array of accumulated empirical evidence and detailed scientific work on the geological history of the Earth, and also on human history, could be brought to bear on this ancient question of the nature of life. Vernadsky defined the biosphere as the entire region of the Earth inhabited by or colonized by living organisms. He called the aggregate of all living organisms existing at any given time as living matter. And he investigated the effect of living matter on the biosphere on the scale of geological time. And the conclusions were clear and unequivocal. I'll just summarize three of them. Firstly, in the course of biological evolution, the aggregate power, which can be measured by something called a free energy ratio, the power of living matter in the biosphere, its potential to do work in transforming its environment, has been constantly increasing. There is no natural equilibrium, but a constant increase in the power of living matter in the Earth. No equilibrium of the sort that these cultish ecologists believe. But actually the biosphere is moving farther and farther away from equilibrium. And as a result of this increase of the power of the living process, living matter has become, according to Vernadsky, the most powerful geological force on the planet. Even though, in terms of total mass, the living organisms themselves are a very small, almost infinitesimally small part of the mass, even of that part of the Earth, the biosphere, which has been transformed by them. So, finally, this specific sort of directed evolutionary development, leading to a continual increase in the free energy ratio or power of living processes in the biosphere, is unique to living organisms and is not found in the non-living domain. Throughout the geological history of the Earth, the basic processes in the non-living matter of the biosphere have remained virtually the same over billions of years, except insofar as they've been modified through the influence of living organisms, including subtle effects, not just gross energetic effects, subtle effects such as the change in the characteristics of water in the biosphere associated with living organisms, and of course the climate and weather. But Vernadsky asked another, even more exciting question. What is the impact of human social activity, taken as a whole, on the development of the biosphere? He saw clearly that in the course of history, the physical economic activity of human society, its agriculture, its industrial production, mining, infrastructure, production of power, water and transport systems, and so on, has had the effect of accelerating the development and growth of the biosphere, accelerating the increase in the power of the living processes, as well as, at the same time, increasing and accelerating the growth of man's own capacity, man's own power to intervene more powerfully into the biosphere in the future, per capita and per square kilometer. How does that occur? As Lyndon LaRouche and Dino will go into this, as demonstrated in a more rigorous and powerful way than Vernadsky could do, this occurs in only one way, through the generation and communication of ideas in the form of scientific discoveries of principle or analogous kinds of discoveries in statecraft and culture, ideas that are bearing on the application of human knowledge to the transformation of the world. And that generation and communication of ideas occurs only within the human mind, individual human minds. So, what Vernadsky called a new state of the biosphere has emerged, in which the further evolution, the further development of the biosphere is being driven by the generation and communication of ideas among human individuals and in human society, the noosphere. And just as the biosphere is a natural product of life, of the living matter, of the living processes, so the noosphere, man's deliberate activity, action on the biosphere to improve the biosphere, reflects a distinct principle different from and higher than that of life per se. As Lynn was saying, human beings provide intellectual power to the biosphere. Now, ironically, we've come to the point that realizing the noosphere, the further development of the noosphere, requires the generation of a very specific new idea. The idea of a discovery of the universal principle of life itself. The principle that is the cause of the unique effects of living processes and their systematic distinction of living processes from all other processes, as demonstrated by Vernadsky. So, Vernadsky's work, as that of any great scientific genius, does not leave us with answers, but rather with the crucial question for us to work on. So now I want to invite my colleagues Larry Hecht, Wolfgang Lilke, and Dino to present illustrations or discussions from three levels of principles: non-living, living, and reason. And I hope we'll set the stage for a fruitful discussion afterwards. Thank you.
So I get to present the non-living. I hope I can keep you alive during this time. The specific subject here is the Ampere angular force. Maybe we've written about this in various places. Maybe I can try to take this little time to give you a clear understanding of what this discovery was. So it begins in the month of September of 1820 and goes into the early months of 1821, a 3 or 4 month period in which André-Marie Ampère, working in Paris, made a great discovery with implications for the future of all science, some we have not even realized yet. We have the privilege in this case, which is not always so, to know more or less exactly the name and address and sequence of events involved in this discovery. With Ampere, we have an excellent example of a revolutionary discovery in science. This is a discovery of principle applying to the domain of inanimate objects, specifically electricity and magnetism. But it is a principle which would qualify, according to the criteria of Vernadsky, as a natural object, the discovery itself. And the most important thing for you to understand here is that, unlike what nearly all of you were taught in school as science, that science is not and never was what the textbooks tell you. It is not this. Science is not this pseudo-religion of an oligarchical priest caste who tell us what we can and cannot believe and mystify and make ugly for us what is really this very human and very much fun process of real discovery. The one thing that this priesthood has never allowed themselves to experience. So science is a process that goes on in the mind of an individual. It is usually derives from a faculty that has been cultivated since childhood. It's characterized by certain features, natural curiosity, a love of paradox, which leads to the development of a concentration span for problem solving, and by joy. It's fun. And if you're studying science and it's not fun, as all of us probably have at some time, then something is wrong. So if that is going on, you've got to stop and reconsider things. Probably some Babylonian priest somewhere is misleading you. So here is where now I get to the Ampere discovery. It begins here. In September of 1820, a Dane by the name of Hans Christian Ørsted came to the French Academy of Science and made a very simple demonstration. We'll get it here, try to get it here for you on the overhead. It involves nothing but a magnetic compass, a wire, and a battery. They had batteries in that time, not quite like this. When the current from the battery passes through the wire, we'll set up the wire first so it's, we'll set up the wire first so it's parallel to the direction of the compass. Yeah, try that. And then just connect the wire to the battery, and we should see something. There you go. Okay. That's all we wanted to see. Thank you. So it rotates. The compass, I've discovered some people aren't aware of what a compass is. It's nothing but a magnetized piece of steel. It's mounted on a very fine pin so it can rotate nicely. So the compass or the magnetic needle is turned by the electrical current. This is something new. It was known that for thousands of years that the compass was turned by the Earth's magnetism. But Ørsted, all the way in 1819, was the first to discover that moving or current electricity, that is what comes out of the battery, affects the compass needle. We should know, to understand why it would take so long to discover that before 1800 we didn't have current electricity. 1800 was the year Alessandro Volta produced the first battery, or voltaic pile as it was called. Before that, the phenomena of electricity we knew of, we had lightning and we had electrostatic generators, which are forms of electricity which discharge in an instant and then they're gone. So Ampere saw this in September of 1820. He was tremendously enthused by the demonstration of Ørsted and proceeded to make an intensive series of experiments at the École Polytechnique in Paris, where he was a professor. Ampere arrived finally at a certain fundamental experiment where he showed the identity of electricity and magnetism. He employed for this a very simple apparatus, which we'll also show you, known as the Ampere solenoid. It consists of nothing but a copper wire covered, insulated copper wire wrapped around a cylindrical form. Let's get that on the overhead. Okay, so we connect one terminal to the battery, and then so we don't run down the battery, we just touch it to the other. That's our switch. Okay. And you see the motion. Okay, you can put it a little closer, and okay, it pulls it right there. just as if, so it pulls the compass needle just as if we had placed a magnet there. Placing a magnet there would do exactly the same thing. So, well, of course, for some of you, this is you probably saw it in the 5th or 6th grade in school, but it hadn't been seen before, and in particular, its significance the significance of it had never been drawn before. It was this fundamental demonstration which allowed Ampere to make the revolutionary conclusion that electricity and magnetism are the same phenomena. There is no separate magnetic and electric field, as you learned in the textbook, because that's what they teach you. Ampere discovered quite the opposite. And if this is so, Ampere reasoned, it must be possible to explain all electrical phenomena and the phenomena which we call magnetic attraction and repulsion on the basis of a single hypothesis of electrical action, a single hypothesis as to what electricity is. So the story here is how Ampere did this, achieved this, realized this hypothesis. Now, what we need to know is at the time Ampere was doing this research, France was the world center of scientific activity. The leading figures of French considered themselves the ruling priesthood of their time, as we have in the American Academy of Science and most national academies today, a similar sort of ruling priesthood. Nasty fellows. Now, their view was completely Newtonian, as today. In France, thanks to some nasty work which had been carried out in the previous century, the French had given up their own form of theism, which was called Descartes, and they had adopted the British form of this disease, which was called Newton. So the Newtonian system is really very simple. You can make it very complicated in the details, and you know, they like to do this to you, especially if you attack it, if you introduce mathematical, logical considerations. But in essence, you go to the axiomatic basis. It is the view of the universe that probably most of you believe in, especially when you go to think about matters of physical science. That's not your fault. You were taught to think this way, and perhaps you didn't realize what was being done to you, or didn't know how to fight it, if you might have had a natural impulse to do so. So what we'll try to do here is teach you this important survival school against Newtonianism. So Newton's view came from not originally, but came through a Venetian by the name of Paolo Sarpi. And in this view, the universe is very simple. There's a big empty container. Call that space. Inside this empty container are objects. And these objects may be made up of smaller objects, which we call particles. So these objects, or the particles within them, relate to each other according to, in this Newtonian view, according to certain universal laws. And when you have really mastered these universal laws, you're able to write down a formula which describes the pairwise relationship between any two of these particles at any place, at any time. Then, predicting the future, according to this view of things, consists of being able to tell you where all the particles are and how fast they are going at the present time. That is, if you know that, their position and where they're headed, then you will know where they will all be at a later time. And that's sometimes called the state of the system. And that's the world. That's the Newtonian world. So by this time, 1820, when Ampere was working, the French Newtonians, under the leadership of Laplace, thought that they had pretty well perfected this system of the world. It had been shown that the three fundamental physical forces which were known at the time all seemed to follow the same universal law, or were describable by the same simple formula. And these three forces were the forces of gravitation, of electrostatic attraction or repulsion, that is, static electricity, pulling and pushing, and of magnetic attraction and repulsion. And it appeared at the time that all these forces could be described by the simple formula that was called the inverse square law. This simply means that if you took two heavy objects, for example, let's say this is the Earth and this is the Sun, that the force between them, they will attract, depends solely on their distance, on the distance of separation. And if you double this distance, the force is reduced not by 2, but by 4. And that's what we mean by the inverse square. So these fellows were very happy and contented with the fact that it was also the case that two electrostatically charged objects, or two magnetic poles to the extent you could try to isolate them, apparently behaved in the same way. Now, Ampère, as we've learned from reading his biography and examining the case, didn't like this game very much. I would suppose that he found it a bit boring. And Ampère, we know, was a close student of the philosophy of Leibniz in particular, and he knew that this view of the universe was rather childish. So he was looking for a way to demonstrate that fact. Now, Ampère knew the Newtonian system very well. He was an accomplished mathematician. He was as good at the manipulations as anybody. But he was a mathematician of the kind which a friend of ours in France, I recently had the opportunity to meet, Professor Maurice Allais, calls the good type. That is, one who does not believe that there is any truth in a mathematical formalism or formula, but that it must be proved by experiment. So, in other words, he puts the laboratory before the blackboard. So, what Ampère did was a very devilish thing for these Laplacian Newtonians. He found a way to blow up their little game from the inside. And by carrying out certain experiments in electrodynamics and analyzing them from a strictly Newtonian standpoint, he proved that this simple unification of the three fundamental forces under the inverse square law did not work. And some people have never forgiven him for it, even to this day. So this is how he did it. One of the fundamental phenomena that Ampère had discovered was that two electrical wires attract or repel each other according to the direction of the current flowing in them. Ampère then decided to analyze the force between these wires. Imagine these are two electrical wires. He decided to analyze it in what might seem to be a very Newtonian way. He decided to reduce the problem to that of determining the force of attraction or repulsion between any two small elements of current in the wire. So you have a big wire, and you imagine a very, very small portion of the wire in which the electrical current is flowing. So these current elements, as he called them, will then be like the gravitational masses of the Newtonian law. They would attract or repel each other. And the question is the pairwise relationship between them governed by this inverse square law or not? So if this is the current element in one wire, this is the current element in another wire, we want to know the force between them. Now, we have to realize we can't just make an empirical measurement of that, because it isn't possible to pull this little element of current out of the wire and out of the other wire, because current elements don't exist separately. They always are part of a complete circuit. You disconnect the circuit and there's no more current. So one has to use some cleverness to figure out experiments where one can mentally isolate the effect of a single small piece or element of the current in one wire and determine its effect on the other element of current. Ampère happened to be very skilled at doing this. And it turned out, to make a long story short, that Ampère's careful researches led to the conclusion that the force of attraction or repulsion between these two elements of current was not simply dependent on the square of their distance apart, but they also depended on the angles which the directions of the current elements make with each other. So, in other words, remember that the wires are not necessarily parallel, but this current element may be aimed like this and like that. So there's actually 3 angles, because this one can also be turned. And geometrically, you end up with 3 angles that would determine their relationship. So Ampere finds that as the directions change, so does the force between them. That's not such a surprising fact, I don't think. We call it the Ampere angular force. About 1825, Ampere completed his researches on this and wrote a long report for the French Academy, which was published and exists to this day. Never translated into English, or I don't know about other languages. Now, 10 years later, we had Carl Friedrich Gauss and Wilhelm Weber working in Germany. Gauss was the senior by about 25 or 30 years, and had taken up at Humboldt's suggestion, had taken up Wilhelm Weber as his assistant. They began to investigate the same phenomena, recognizing the tremendous significance of what Ampere had found for overthrowing the entire Newtonian view. They use a different type of apparatus and a slightly different hypothesis about what the current in the wire consists of. However, they come to the same conclusion. In their hypothesis, the current consists of moving electrical particles. And their results showed that the force between these moving electrical particles was dependent upon the relative velocities of the particles. But the dependency was measurably the same as that determined by Ampere. And thus, Weber wrote in 1844 that Ampere's law was conclusively proved. This is not accepted even to this day, which can only be explained as the ideology of a Babylonian priesthood which governs science today. It is not permitted to believe that anything other than the inverse square law exists as a fundamental force in this realm of physics. So, in James Clerk Maxwell's reformulation of the laws of electricity, which occurred between about 1858 and 1868, his work on electricity and magnetism, the Ampere angular force, or the Weber force, which is dependent on the relative velocities, is conveniently ignored. And if you question the defenders of the Maxwell view, which is what is universally taught today, they will make the argument that we don't really have empirical confirmation of the Ampere angular force for the reason I told you earlier. One can never isolate these individual current elements. And in fact, it is the case, as Ampere well understood, that if you want to be such a crude empiricist about it and only look at the effect of one whole circuit on the other, that the angular force in the totality is eliminated when you integrate the effect of the entire circuit. So foolish empiricists suppose they can ignore the effect. They ignore it at their own peril. For it turned out that in the hands of Weber, who lived into the 1880s, this discovery of the importance and the proof of the Ampere force and his discovery of its establishment of its existence led about 1870 to an advanced understanding of the atom. Weber's paper of 1870, which was my introduction to this whole matter, describes the structure of the atom, today called the Rutherford-Bohr atom, which was supposedly only arrived at about 43 years later, in 1913. But not only was Weber's conception far earlier, but is absolutely superior to the modern accepted view for various reasons. For one, Weber describes many phenomena which cannot yet be lawfully described today. For example, his description of the orbital motion of the electron is a lawful description deriving from his electrodynamic law. We don't have that in the present view of things. And perhaps even more interesting, his prediction of the reversal of the Coulomb force That is, by that we mean that like electrostatic particles repel. Weber was able to recognize in 1870 that this repulsion of like particles would actually reverse itself below a certain very small length. And those of you who know about this may realize that has tremendous implications for the nuclear physics, questions of fusion or the binding energy of an atom. Again, something completely not accepted, buried. So, there are many other interesting things in connection with this I have spent a lot of time looking into. We'll have to present them at another occasion. For now, I want you simply to get an idea of this process by which a sovereign individual mind makes a scientific discovery, a discovery which can fit the description of natural object, as Vernadsky called it. And I want you to understand that such discoveries are never represented in the textbooks and can never be learned by the fashion of education that works like this. Thank you.